Hello, let's evaluate this integral. I equal to integral 0 to infinity sine of ax by x power n dx, right? So this can be written as integral 0 to infinity sine of ax into 1 by x power n dx, right? So we know a mass identity, which is integral 0 to infinity f of x into g of x dx is integral 0 to infinity Laplace transform of f of x into Laplace inverse of g of x into dx, right? Here let's consider f of x as sine of ax and g of x as 1 by x power n. So our case I equal to integral 0 to infinity sine of ax into 1 by x power n dx can be written as integral 0 to infinity Laplace transform of sine of ax into Laplace inverse of 1 by x power n dx. Fine. Then I is integral 0 to infinity Laplace transform of sin ax is a by x square plus a square, right? What about Laplace inverse of x power n? It will be x power n minus 1 by gamma of n, right? Into sorry dx. Fine. Then as you know, this a and gamma of n are constant. Keep it out of the integral. Then integral 0 to infinity x power n minus 1 by x square plus a square dx. Fine. As you can observe in the denominator, it's x square plus a square. So let's make a substitution here. Let's consider x as a into root u. Fine. Then dx will be a into root u will be 1 by 2 root u, right? Then this can be written as 1 by 2 root u into du. Fine. Then what about the integration limits? Integration limits will, if x equal to 0, u will be 0. If x is infinity, u will be infinity. So integration limits will not get changed. Then let's proceed to write I. Then I is a by gamma of n into integral 0 to infinity x power n minus 1, right? X is a root u, a root u whole power n minus 1 by x square is a square into u plus a square. Dx is a by 1 by 2 root u d. Fine. Then I is, right? Then I can be written as a by gamma of n into integral 0 to infinity. This will be a n minus 1, and there is one more I here. It will be plus n, right? Then what about this u term? U n by 2 minus half, right? By, if you take a square as common here, it will be u plus 1 into 2, right? Into 2 into this root u will be, if it brings in the numerator, it will be u power minus half, right? Minus half du. So finally I is this will go, then this will be a power n, and this a and this a, this will be I is a power n by a, right? A power n minus 1 by 2 into gamma of n into integral 0 to infinity. Here you can see it's u power n by 2, minus of is minus 1 by u plus 1 into d, right? So let's proceed here. Let's proceed. It looks like a beta function type, right? Let's make it in the form of beta function. It is a power n minus 1 by 2 into gamma of n into integral 0 to infinity u power n minus n by 2 minus 1 by how can you write it as u plus 1? U plus 1, as you can see here, it can be written as n by 2 by plus 1 minus n by 2 into du. As n by 2 will get cancelled and u plus 1 whole power n plus 1. So this looks like a beta function, right? Let's write it down. The function beta of m comma n is integral 0 to infinity x power m minus 1 by 1 plus x whole power m plus n dx, right? If you compare these two functions, we can say here m is n by 2, right? This will be m, and n is 1 minus n by 2. So I becomes a power n minus 1 by 2 into gamma of n into beta function of n by 2 comma 1 minus n by 2. As you know, the formula of beta function, right? Beta of m comma n is gamma of m into gamma of n by gamma of n plus n. So I becomes a power n minus 1 by 2 into gamma of n, and this becomes gamma of n by 2 into gamma of 1 minus n by 2 by gamma of n by 2 plus 1 minus n by 2. Fine. This n by 2 will go, and the remaining is gamma of n by 2 into gamma of 1 minus n by 2, right? And gamma of 1 is 0 factorial, which is 1. So as you know, this Euler's identity, let's write it down. From Euler's identity, gamma of x into gamma of 1 minus x is pi by sine pi x. So in our case, I is this term, right? So write this term here. Here it's a power n minus 1 by 2 gamma of n. So here it is a power n minus 1 by 2 into gamma of n into pi by sine of pi to x. Here it is n, right? N by 2. Fine. Then totally our integral 0 to infinity sine of ax by x power n dx is a power n minus 1 by 2 into gamma of n pi by sine of n pi by 2. Fine. This is the result.